Good morning, everybody. Welcome all, and thanks for attending today. I'm sure there'll be a few that continue to join as we get started, but I think we'll kick off. So appreciate your attending on what I'm sure will be an exciting and informative webinar on in-building coverage. My name's David Birch, and I'll be facilitating today's session. It's great to see such a diverse audience from across our existing customer base, prospective new customers, as well as a number of technology consultants joining us today. So for those on the call who are perhaps not too familiar with Progility, a very quick introduction. Progility is an Australian systems integrator. We've got a history of over 30 years experience deploying a broad range of business and mission critical communication technologies. Our capabilities are very diverse and span unified communications, push-to-talk and two-way radio, IT and OT networking, security, communications infrastructure, location-based services, asset management, tracking, and in-building coverage. We champion innovative technologies to deliver tomorrow's solutions today to many of Australia's largest companies. With over 85 staff based nationally across Australia, we have the capability, skills and capacity to deliver projects of all sizes and complexities. Now, onto the subject of our webinar today, which is regarding disrupting in-building coverage. And at this point, I'd like to introduce our subject matter expert, Stu Hunter. Stu has a long background in RF engineering, dating back into the early 80s. Stu has been a subject matter expert in cellular communications since 1995, having worked for over a decade each with both Telstra and Optus. He's been helping customers resolve their mobile coverage challenges since 1995 and moved into the niche space of in-building coverage over a decade ago. One of Stu's strengths has been his ability to bring together the thinking from both a customer and telco perspective to drive technically effective and commercially attractive in-building coverage outcomes. Stu has also been instrumental in the advocacy for the newly released Selfie products, which are driving effective solutions for customers into the future. Welcome, Stu.
Thanks, Dave.
So, without any further ado, we're going to dig into the topic of the day. So while Stu and I are discussing the topic, we'd encourage you to add any questions into the Q&A. There is a Q&A button at the top of the window, and we'll try to handle these either during the chat, at the end of the discussion, or as part of our follow-up. So please feel free to drop as many questions in there, and we'll deal with them as we go. So I'm going to open up with a couple of IBC 101s. Firstly, probably dealing with some of the terminology and acronyms to make sure that everyone's on the same page. So, Stu, first question, in your mind and for the audience, what do we really mean by IBC or in-building coverage?
Thanks, David. Firstly, we'll just confirm that we're talking about mobile and cellular in-building coverage because there are other forms of it. However, it's essentially being able to use your mobile phone indoors, often in a corporate space. And what we see is that modern buildings and other things tend to impede the performance of mobile phones indoors. We use our phones as a first form of communication, so we want our phones, computers, devices, FPOS terminals to work reliably indoors. In-building coverage is about improving the quality of mobile coverage inside a building because of an inability of the external network to provide service. Is that satisfactory, David?
It is, Stu. Yeah, that really helps. So the other acronym that we commonly hear is DAS. So can you explain what a DAS is and how it's related to or different from IBC or in-building coverage?
Yes. IBC is what the customer wants. They will go to their provider or go to their builder or go to the organisation that they're trying to get a result from, and they usually want an in-building coverage solution. What I've seen and explained with customers and heard from customers is, imagine a new building. A builder might say, oh, that's a DAS, I'll build you a DAS. Well, a DAS is only part of the solution. So a customer wants in-building coverage. A builder puts a DAS in for them, and then maybe on opening ceremonies day, there's actually no service. It's an incomplete solution because it's lacking the vital component that makes it operate, that illuminates it with signal. Now that could be a carrier base station or radio base station. It could be a repeater solution where the repeater equipment and all the antennas are integrated. But the customer wants in-building coverage. The rooms that they often have in their buildings are called a DAS room, but the DAS is not in the room. The DAS is in the building. In the DAS room is the carrier equipment, and sometimes there's none at all. David Sorbia and I have been working on a building in Sydney where the DAS has been there for 9 years, but there is no carrier base station. We won't talk about that specifically, but that's a good example. We might even later on if we need. However, there's a little equation. In-building coverage equals DAS plus base station. And as someone mentioned the other day, or the equipment you use to make the DAS work. It's electronic equipment that takes up space and costs money and takes a while to get put in.
Thanks, Stu. So in summary, really what we're saying is that in-building coverage is the overall outcome to a customer providing coverage inside a building, but the DAS is effectively the physical equipment which is used to distribute the signals throughout the building.
Yes, and it's called a distributed antenna system. That's what DAS stands for, because numerous small antennas are installed usually under the ceilings throughout the building to sprinkle signal or to distribute the signal throughout the building from the main source, the main cellular source. And that's really what they are.
Good. So we've got the terminology understood. Now, let's go back to thinking about the problem and the cause. So maybe give some context, why do the problems exist? Why are there many buildings out there that just experience really, really poor mobile phone coverage?
Yes. Look, some of the thing is come as our reliance on mobile phones has increased over the years. So the usage of mobile phones as an indoor device, as the first communications device for a whole bunch of reasons, and desktop phones have gone away and all of these other things. It's a really multi-technology capable device, but it needs foundation mobile coverage to operate. The other thing is that people want things to happen more quickly, more instantaneously, more responsively. And so if you are in a poor coverage location, anywhere to be fair, your device performance lags, falls away. Now, in a building where people live and work and operate, there's just a higher density of users who need to get a good, reliable service. If you look at a modern CBD where they're becoming more densely populated with more closely spaced or placed buildings, there's also fewer opportunities for external mobile towers to be put in place to service this increasing usage. You just need to come up with a better way. And the way is to put an in-building coverage system into your building. We'll talk about a specific product that's disrupting the middle space, the middle prize of the market. It's not the solution to every location and every need, but it's a great solution to an area that was essentially unable to get a good result for a very long time. And of course, this product's only been in the Australian market since May of 2023. We're just putting on screen an image of a typical candidate building for a product called the Quattro 4000. It's an Activity Corporation product, Cellfly Quattro 4000. It can service typically a building of around 25,000 square metres. And on screen here, we're looking at about a 9-storey building with a couple of levels of underground car park. Typically, a building like this would get a solution that was over-engineered, big, suitable, wonderful for the site, but way too expensive and take too long to deliver. So often they would go to a smaller product. Maybe, Camilla, can you find the slide on the continuum for me quickly? It would show that before the Quattro 4000, the smaller products just weren't ideal, but it was all people could buy, and they would encounter problems. So we're seeing here a list of the gear. Maybe that simpler slide, if we could. Yes, here we show it. So this is the array of Nextivity hardware that's available in the Australian market. In the bottom corner, you'll see stuff that's greyed out. So that equipment still exists, but it's obsolete and it's not really retail sold anymore. And as we move up the scale to the upwards and to the right, you get larger, more capable equipment with more functionality. The Quattro 4000 is the first product that integrates service for all mobile networks in Australia into one piece of equipment, and it's expandable. You have a main unit with up to 6 modules, and then an extender which can add up to 6 more. That complete kit can service a 25,000 square metre area. Camilla, if you can flick back to the more complex slide, it kind of shows that the Quattro 4000 is not a solution across the board. It's a choice. It's uniquely positioned, but it's in about the middle of the market in terms of area, size, expense, and delivery. In the bottom, you'll see I talk about it taking 6 to 9 months. Well, actually, it doesn't. That's typically the timeframes you'd see on carrier equipment, like is underneath the picture. Quattro 4000 has been delivered in large scale in very short time, and we'll talk a bit more about that shortly.
Thanks, Stu. So as we're starting to see that there's clearly a number of different things out there that are sort of creating coverage issues, different types of buildings, different kind of factors over there. But I want to dig in a little bit further and say, well, if we understand that there are buildings having these challenges, what are then the problems that are arising as a result of not having good in-building coverage? What's the impact out there? Because it's probably changing over time as well.
Yes, I think so. And even things like the cessation of 3G in Australia has raised people's awareness about mobile coverage and how they will cope in the changing technologies. But something that's interesting to note is an outcome of scamming that's occurred in financial transactions over the years. The federal government a couple of years ago essentially directed the financial institutions to look after their customers better. Well, what did that mean? They implemented things like two-factor authentication or authentication codes sent to a mobile phone to confirm that the transaction being done was authorised by the owner. They sent it to the phone. Now, if the phone has no reception, that text message doesn't arrive, and they may have the funds, they may be at the point of sale, but the transaction falls over because of a missing transaction code. We're seeing other instances where scam can cause people to suffer loss. Telcos implementing confirmation text messages to customers when they change something on their plan or they change their phone. And so a business that succeeded in inviting a customer to join their network, so say churning from Optus to Telstra or Telstra to Optus or the other way, the losing player actually has to send a message to the customer saying, was it really you that requested this churn? Now, if that doesn't happen, the transaction falls over. It causes a lot of frustration on all sides. We're seeing more and more of these instances where applications, use of Microsoft Authenticator, use of SMS and notifications to apps like financial apps fail because of lack of connectivity. That has a knock-on to our customer's customer. We might be dealing with a large national retailer who have customers from all operators coming in and shopping in their stores, unsuccessfully unable to complete their transaction because of poor comms. I spoke to a retailer the other day, and they have many stores across Australia, and he said simply that he's got retailers that receive new EFTPOS terminals from their banks, and they just don't work. So here's a simple problem where these EFTPOS terminals, hundreds and hundreds of EFTPOS terminals being shot around Australia by the bank to the retailer, can't work because they have no mobile coverage. So mobile coverage is far more vital to business to occur now, and for usage and for convenience of people and for their personal financial security than ever before, right? We know that parking operators like to use apps to have people pay for their parking when they come into a boom gate or to be authenticated through their monthly account. So we're seeing more and more where the reliance on a working mobile phone, usually through the mobile network, we know that there are options with Wi-Fi. We know there are options, but they complicate. And many just want to solve their problem with Wi-Fi, with cellular. Now, interestingly, they can't afford to wait for a legacy system to be deployed. It's just unpalatable. So they're looking for a faster, smarter, more economical solution, and products like Quattro 4000 are that.
thanks, Steve. Some good examples of the impacts on end users in that sense. So you've had the benefit of working both on the carrier side as well as consulting with customers and seeing a wide variety of solutions. So just getting back to more probably about the question of the topic of the day. How is this in-building coverage space being disrupted by these new technologies? So what's kind of the change happening out there, and why is it driving disruption in the market?
So as I was saying, the middle space, which is where we think this product is ideally positioned, has never really had a suitable solution. They've attempted to use smaller ones in multiples. They couldn't really afford to deal with the complexity and time and cost of the larger systems installed in a smaller space. Sometimes the operators aren't really able to commit the time to that because they're so busy maintaining the big and growing their in-building coverage network into bigger, more higher priority locations. An example might be that there are hundreds of hospitals around Australia. Last count I saw, there were about 1,200 hospitals around Australia that didn't really have an in-building coverage system. They were relying on external ambient reception from nearby mobile towers. Now that may or may not be useful, but there are many hospitals that do have in-building coverage, and there are many more who require it. And so many commercial spaces, especially in this middle space, simply miss out on the priority list. They also can't afford to wait, either to get onto the priority list or wait for the solution to be deployed. They're looking for a better, faster, less complicated solution that can be deployed rapidly. And to cut a long story short, we've had deployments where we've done 25,000 square metres in 5.5 weeks. And it's been a complete system deployed and effectively sunk without trace. Maybe it'd be a good time to introduce our guest.
Yeah, I think it's good, Stu, and it's great to kind of hear maybe kind of the aspect of vendors are listening and responding to the evolving needs of the market. So that's great. At this point, I'd love to welcome David Sorbier, who joins us from St Vincent's Hospital, Australia, and holds the role of IT Communication Manager. David, thanks for joining us and giving us some time today. So we've been fortunate to work with you over the recent past with putting a solution in place for the Mater Hospital in Sydney. Would love maybe first open up and talk to us a little bit and the audience about the challenges that you were facing at St Vincent's. What was the motivation and prompting to investigate a solution, and then what the experience has been as a result of deploying the outcome that you've gained.
Yeah, thank you. So we had a bit of a unique situation at the Mater Hospital in North Sydney. We had multiple escalations from the executive level of the hospital. We're also constrained by space to be able to put a DAS in. And we also had timing issues between our network modernization, which would allow Wi-Fi calling for the doctors. But then we also had issues with patients and visitors being able to communicate between each other for patient pickups and mobility. So that's where I've worked with Fragility for about 20 years on different PABX solutions, and then reached out to Fragility in this space when I heard about the Quattro 4000. The Quattro 4000 being multi-carrier was one of the driving factors that we actually went towards this solution in this instance. Not needing that whole DAS room, which a lot of hospitals, you just cannot get that space. Even hospitals that we're building at the moment, they're looking to reduce the size of that DAS room wherever they can. So we're mainly looking at the operating suites, ICU, critical care, our birthing suites at the Mater Hospital, and also our day surgery suites, which were in a different building. So that also provided some extra complexities to getting an overall solution, which I found the solution from Fragility with the Quattro 4000 easily met those requirements. our experience with Fragility to actually get the solution in, it was very fast once we had all the sign-off from the executive and legal. The whole experience to actually get the solution in and to provide coverage and get it turned on was very seamless. And at the end of the day, everyone was happy.
Yeah, I mean, I think from memory as well, we were very early in the journey in utilising the Quattro 4000 technology with yourself, and I think one of the things that we found really beneficial as well is that originally, two of the mobile carriers had provided approval, but we were still waiting for approval of one. But we were able to actually go ahead, install the technology and activate to provide coverage for two of the three mobile carriers in Australia. And then when approval came through from the final carrier, it was literally just flicking a switch in the software and the third carrier came on board. So traditionally, where you may have deployed a technology solution with different aspects for different carriers, this was a single carrier solution that could just then be activated once all the approvals from different carriers came through. So yeah, so really flexible in terms of that. And David, just in terms of, you know, one of the things post the installation, feedback. I think, you know, kind of something we talked about before and you've spoken to Stu about is just, it's gone quiet.
Yeah, like once the third carrier got turned on, we've had no complaints from mainly the visiting medical officers, which was our biggest pain point. We just do not hear from them now. They've got full coverage in all the operating suites and ICU, so they're contactable all the time.
I suppose David, I'd like to amplify that bit too for both Davids. I was frequently a bit unsure why this was so important to VMOs. I was in conversation with a nurse at one of the other St Vincent's properties recently, Sorbia, and she gave me a very succinct explanation, which was that a VMO might be working in a hospital in the morning doing some procedures and then be in another hospital in the afternoon when they're trying to contact the VMO about a recovery that's not going to plan. And if they can't get hold of that doctor, then the recovery can be compromised and it might end up in an overnight stay when in fact just speaking to the doctor might have been a modification in medication or something or other, and instead of going home at 4 p.m, they go home at 5 p.m. So this really exasperates the VMOs, it frustrates hospital operations, and just being able to be contacted, it's really stressful for the nurses because they can't change the care to the patient. It's frustrating to the doctors who are busy people and can fix if they're just contactable. And it was simple as them just not being able to be connected to. So it's a bi-directional thing. But what we now know from what you've said is the VMOs working at Mater Hospital in Sydney can be contacted. All of the patients and all of the staff there. And as you said, you've got contractors and all these other people. And what we've done, the thing I really like is that we've helped you help your customer. And that's what we're doing. It's, you know, it's really nice to be reaching past the businesses we're working with into their customer base and making their customer base have a better experience. And the wonderful thing and why I believe, and we've been told by some of our other customers that the Quattro 4000 is very disruptive. So it's not really a statement. We're making the statement, but we've had it said to us by builders, by state government construction departments who have been surprised at almost how relaxed we've been about the timeframes. Sometimes they've given us insufficient time and we've said, well, actually, for this product, it's not insufficient, it's just in time. And we don't want them to waste it. But if they give us a month or 6 weeks or 8 weeks to come up with a solution because they've just discovered they've got a problem, not in all circumstances can we solve it, but in many circumstances we can. We're also increasingly seeing new use cases for Quattro 4000, which I might talk about in a minute if we get to it, David. We're nearly halfway through.
Yeah, no, that's all good. And I just want we're talking about the Quattro, and David, thanks for the input, really helpful, and it's great to see such a great outcome and result for St Vincent's, the hospital, the VMOs, the patients as a result. You know, that kind of, you know, throughfare of the benefits is fantastic. But Stu, a question I'm just going to call because I saw this one on the Q&A come in, because we are talking about the Quattro. James Neal's asked, does the Quattro replace the DAS? Because we were talking about the DAS earlier,
yeah, good question.
New product, so it's a good timing of that question, I think.
I think it's an excellent alternative to a DAS, to a passive DAS that might be put in requiring a base station or a radio base station. So we do have a good example customer in Sydney last year who needed to service about a 12,000 square metre area. They were ready to order a very expensive DAS system that still wouldn't have had base stations. So they were going to put a DAS in, and then we were introduced to them and they pivoted and went with a Quattro 4000 solution. And so far our estimate is their savings in initial investment is over $500,000. But it wasn't about the saving, it was about the solution. They wanted in-building coverage. They didn't just want a DAS. So does Quattro replace the DAS? Side by side, yes, it does. Quattro still has a very small DAS around every coverage unit. So I'll try to describe in a word picture. It has a central unit called a network unit connected to donor antennas. That network unit can feed 6 to 12 coverage units, and each coverage unit has a small set of antennas in its vicinity. What we found is the optimum design is a coverage unit feeding 4 antennas, which can do about 1,850 square metres to 2,000 square metres if your building is rectangular, and nearly all buildings are. So quick answer is, does Quattro replace the DAS? My answer is yes. It uses its own localised antennas. It uses the same sort of antennas and the same sort of cabling. It's just configured differently. James, if you want to give me a thumbs up or a follow-on question, please do so. And if we need to, maybe we meet later, but hopefully that explains that question.
Yeah, I think it does, Stu. And I follow it on, there was another one by Nithya that came in. We're talking about kind of, I guess, you know, coverage and whatever, capacity. So are there limitations around users of a Quattro 4000, sorry?
Yeah, so that's a good question. This device relies on the donor signals that we take from the surrounding network. So we do quite a bit of work in the assessment of the quality of those donor signals. We in fact submit our findings to the operators and seek their opinion on suitability. And we like to select a primary, a secondary and a tertiary site so that we've got options. The Quattro system does not deliver its own capacity. It takes capacity from the surrounding network. So yeah, there could be some capacity constraints, but a really important thing to consider is that it's a 3-network solution, and it actually has the capacity to use all of it. The way we deploy it, we use all of the internal resources in the Quattro, and that is 8 4G, 5G radios boosting 8 different bands across the 3 networks. So what we find is it manages demand quite well, but I wouldn't go putting it into a convention centre where at lunchtime and morning and afternoon tea, you could have 3,000 people coming out to the coffee shop trying to check their phone and their text messages. It might cope well, but it's unlikely to be able to deliver all of that peaky demand that often happens in those peaky environments. So it's a fairly case-by-case thing. Who was the questioner again, please, David Birch?
It was Nithya.
So Nithya, we'd probably want to talk, give us a couple of examples. We talk to you maybe separately about the cases that you have in mind. If you remember back to that 12-storey building or 9-storey building we showed earlier, this is a middle price solution. We're not talking about putting it into a major event centre or, you know, something like that.
Thanks, Stu. So, you know, the focus of the product or whatever, we're typically talking about this middle price commercial buildings up to 25,000 square meters, as you mentioned earlier. So, you know, we regularly hear that property owners and facility managers are beyond frustration with how hard it is to get cellular coverage into their buildings. So from your own thoughts, Stu, why has it been so difficult for them to get this coverage? And even thinking about, kind of thoughts on legacy DAS systems and alike, just kind of share some thoughts with the audience.
Sure, yeah. So one of the challenges is all the different perspectives that apply into the negotiation. So you've got a property owner who wants to provide service into their building. They probably think that it should be something that's automatically deployed because the operators have got all this external mobile coverage. Why isn't it working inside my building? Well, the operators are not actually required to provide total coverage everywhere. They're providing this broad spectrum of coverage around a place. It's essentially people and vehicles moving around at ground level. When you modify that reception by moving indoors, and also modern buildings are getting more and more insulated, more and more dense, larger scale, the poor old mobile signal just does not penetrate far enough to be reliable or consistent inside the building. You can make a reliable and consistent in-building signal by putting an internal system filling the building with service. You also want that system to know where it is in relation to the cellular network, so users exiting and entering the building have a good experience. But it's not incumbent upon the operators to build an in-building coverage system, much as people would like them to. They're also busy building their macro networks around Australia, and we know that they're competing with each other. They do collaborate when it comes to putting connections into DAS, but it's happening less and less. And particularly in our space, this middle prize, they're often missing out. Now, smaller, older repeater systems were often deployed in this space, but they're only for one operator. So Optus might put a repeater system in, or Telstra or TPG, and that's actually quite common. There's thousands of those repeaters around the Australian market. But one thing that's happened is many of those carrier deployed repeaters have been displaced by these third-party available Nextivity products, and the Quattro 4000 really serves that space well. We've now got 2 examples of customers that are moving on from what they put in a few years ago, which was all they could get and didn't work very well, but it was better than nothing, now transitioning across to Quattro 4000 because it's the right product in their building space. The thing they love is 3 operator networks, each operator getting a minimum of 2 bands of their service boosted. And with some funky design, we've been able to allocate the other bands to the preferred operator as well. And the customers get all of the resources delivered through this system. Now, you used the word modular earlier, David. When we were talking to Marta and David Sorbia, you'd remember this. The original design budget was to put 8 of the CU modules in, because that was all the money was. Then we added a 9th, because people realised that there was an important corridor down low that needed to be served. But then the GM said, no way, I don't want any of the business missing out. Please put 10, 11 and 12 in. But we also deployed it in a modular way. We deployed it first CU and antennas, then the second, then the third. And we reached a point where we almost had people rolling out the welcome mat. They went from doubtful and fearful about us disrupting their business to welcoming and saying, well, why are you starting on Thursday? Can you come in tomorrow? We'll make the space available. And the total deployment was reduced from an estimated, I think it was about 8 or 9 weeks, was reduced to about 5, because the users in the property got excited. We also didn't leave anyone behind. And just recently, we've been asked to add an additional node to an area of the hospital that's been redeveloped. So it is a really modular product. Each module is unaffected by its neighbours. That's why it's modular. So we could put 3 in, we could add a 4th or a 5th or a 6th or onward to 12th. And the original design that we did is effectively unaffected. And so we can just move forward. We don't have to keep going back to the previous and changing it. We're seeing that with existing DAS, where they're finding that they're inadequate and they're wanting them to be remediated, supplemented, augmented, whatever words you want to use. Basically, the DAS we've got is not good enough. We need a bit more. We're not ready to replace it. How can you help? That sort of thing are happening. All right.
Yeah, thanks, Stu. That's a really kind of helpful approach and some good thoughts in there. So the other thing I want to consider, and there was a comment about a little bit earlier about the 3G network turning off. So what's the kind of thinking here? So with 3G going, with new technology coming along, how do these things coexist, or should organizations be thinking about rip and replaced for legacy DAS because 3G has gone and they need new, or, share some thoughts around kind of this transitional technology space, particularly with network changes as well.
Yeah, and it's interesting. When 2G was created, it wasn't called 2G. It was called GSM. And 1G has never been talked about. You never hear anyone talking about 1G because it was the first. So the generational changes through mobile networks have been a phenomenon that we are part of as people demand more, require more. But they really just use the same frequencies that the carriers have always licensed. I mean, there's a couple more frequencies that have been bought for the high end of 5G, but essentially they reuse the frequencies. A lot of the technology that's out there can operate on the same frequencies it always did and may not be able to cope with the bigger, higher frequencies that are valuable for extra bandwidth and extra throughput for users. That's, internet access and getting data faster. But they're often able to be used to some degree. If they're able to be used to some degree, then there's only a degree of modernisation required. Now, if someone's refitting a new building, possibly completely gutting the building and refurbishing a building that might be 40 years old and then trying to modernise the whole building, they may choose at the same time, because the whole building is out of service, to replace not only the electrics and the in-building management system and even upgrade the elevators. They may choose to replace the DAS in the building. But that's less common. What we're seeing is people really trying to sweat their building asset. They're trying to find a way to use what they have and extend the life of it. And we would advocate in many cases that they should consider replacing their DAS. Now, if they do consider that, they still have a transition. What do we do while part of the DAS is removed or whole of the DAS is removed? We can creatively use Quattro 4000 with appropriate design and liaison and consultation with all the key people, including the operators. We can even use that as a bit of a stopgap in some places in a building. And it depends on the needs. But there are over 2,800 DASs in Australia, in fact, well over 3,000. There would easily be 2,000 of those that need a touch-up, a lick of paint, a bit more work, some components to be replaced. As at the same time, ensuring that those old systems that tend to have base stations connected to them are also going to get complementary upgrades by the operators. When I say complementary, not free, but to complement the work. If you were to spend money on your new DAS and the operator doesn't, for some reason, hold up their end of the bargain, for want of a better title, then that investment is potentially wasted. The thing that's lovely about the Quattro 4000 in the right space is it'll repeat 3G, 4G and 5G. We don't need 3G anymore. That's okay. People still worry about it. It repeats 5G up to 2600 meg. It doesn't do the high band, what they call band 78 5G frequencies that the carriers have invested billions of dollars into, both in licenses and infrastructure. Some would say in the buildings we're talking about, it probably doesn't need to. Now, that's another debate that I can have with anybody. But when you go to a property that's 25,000 square metres and you suggest to them that fairly rapidly we can deliver a solution that will give them 4G and 5G and fix their coverage concerns, many are happy. We are encountering users who don't understand the implications of the turn-off of the 3G network. We're seeing end users who still don't know that device settings or device configuration or even device spec is important in them being able to use it as a 4G phone or a 4G modem. And we're still encountering that. And I suppose that will continue for a few months where we get pretty distressed people, and then we deal with those on a case-by-case basis.
Very good. Stu, I'm going to jump to a few of the questions that are coming in, and please, to the audience, please keep firing some questions in. We're going to start going through a few of these now. We've got a few coming through. We've even had a few that have been pre-asked on the way, but let's jump in. So Vern Mitchell, from Centre Group, thanks for your question. So it's a great question, and one that I know is coming up more and more, not just about Quattro, but about kind of IBC and DAS systems overall, is about active monitoring of a Quattro system to help improve performance and maintenance. So maybe let's even expand on that one, Stu. Let's answer the question about the monitoring capabilities of Quattro, but also what about monitoring of DAS as a whole?
Yes, so we briefly covered this earlier. Legacy DAS, they're either a completely passive DAS where there's no electronics in them, or sections of them are passive, and there might be some remote units distributed in the building. But they're just cables, connectors, and antennas. There's no function in those per se. They're called a passive DAS because they're not powered. They can be damaged or they can fail, and the users won't know. So the building operator often wants to know the status of their facilities, and they're blind with this. And funnily enough, the network operator might say, well, our base station is working quite fine, or we might be seeing some noise or some interference in the front end of our system, but that doesn't tell us where the issue lies. And by the way, it's your DAS, you put it in, or you had someone put it in, so go and fix it yourself. So there's not much guidance there, right? We, as I was saying, we're developing a product offering where we can put some. We've heard of that old story about canaries in the cave that detect gas, and if the canary dies, you've got to get out of the cave pretty quickly, right? So these devices are like a canary in the DAS. They're scattered around inside the DAS, and what they do is they monitor a whole bunch of criteria on the network performance at a radio level, at a signal level, and then they give us indications about changes in the performance. It could be trend, or it could be instance, so it could be a fault, a cable cut or a cable damaged. And these are often done inadvertently by trades in the building doing other works and not understanding that they have impacted a system. That event may not really be noticeable until people start to complain. And that complaint could take months and no one can really recall. The monitoring system lets us have a histogram. We can go and see the change. We can identify the contributors and we can resolve it. We can also, in time, we expect to be able to set threshold alarms and other things. That is under development. This is an early stage product. We're very excited about where it's going. A colleague on the call, Greg Higgins, is our product development manager, and he's knee deep in this. We'd happily talk to people who need to have their DAS monitored. It is a managed service. Now I'll move across to Quattro. Quattro can be described as a hybrid DAS. It has active elements right up to the last few antennas within meters of each coverage unit. The coverage units are connected to the network unit using what looks like Ethernet cable, but it's not an Ethernet connection, it's Cat6. They can also be connected with fibre over to allow them to be significantly different, spread across a large area. All of this electronics and the design of the system allows it to be centrally monitored and centrally observed. There's a portal that all of our systems are connected to. Camilla, can you find the photo of our map in Australia, please? The portal reports the health status of all the systems. So this is just the install base of Quattro 4000 that we've got. The blues versus the greens. Where there's the green, there's one system. Where the blues, there's a number of systems at that location, and if we zoomed in the dynamic map, you'd see them. But you'll see these scattered around Australia. This is our core reporting platform where we start to see colours change when a system develops a fault and it reports those into us. So the Quattro 4000 system monitors all the active electronic components right out to within meters of the antenna, which gives us a lot more visibility of the health of the system. And it also allows things like periodic software updates and periodic maintenance and other things all to happen from our network operations centre. And it just means that we can give our customers some peace of mind that the Quattro system is monitored, and we're working on monitoring the legacy DASs so we can provide a broader solution. I'm not sure the operators think a lot about monitoring DASs because they don't necessarily want to be held to account. We certainly have found instances when we've done benchmark testing, so we often go in and benchmark people's DAS to see how well it's performing. That's every antenna, every cable, every bit of square foot of the floors. We will find that, for example, an operator's not using all the spectrum that they said they were. Customer may not know that. They're just seeing a poorer service. and we will politely inquire of the carrier, hey, why is this band turned off? There could be very good reason, but people need to be informed and know what to do with that. This is what monitoring is about. It is still, in my view, a reactive monitoring, but we're moving towards systems being able to alert us when it's got a problem, and that's usually a serious problem. We even use comms links that allow us to let us know if the comms link has gone down. So we can see the comms link, we can see the equipment, we can see the equipment deep in their network, and we can report on it nationally. I think that's a big improvement over shrugging your shoulders and saying, we'll send a technician out, which has often been pretty close to all you could do.
Yeah. Thanks, Steve. I've had a question from Les Clark from Epworth. Thanks for your question, Les. So question is, Stu, what sort of infrastructure is required between the areas, and are the donor antennas on the roof per carrier, etc.? So maybe just describe the kind of the infrastructure of the system.
Okay. Yes. So the donor antennas are usually roof mounted, but they're not always roof mounted, because sometimes that's not the best place to get a donor. When you get up high, you often pick up a lot of noise and interference. So we find the most suitable location to mount a donor antenna, and that could be at a lower level on a building, but let's say a roof for this. They're external, they're pointing to the donor sources. We can take donor signal from DAS signals in a building, particularly when we're extending coverage beyond where the DAS used to serve, like a shopping centre that's expanded or a hospital campus that's expanded. We can use signal from the DAS from a base station inside the building as a donor. That is then taken to the Quattro 4000 network unit. Now, I like the Quattro 4000 network unit to be relatively close to the antennas. So you'd imagine the antennas are on the roof, the Quattro could be in the plant room or on the high level floor. It can occupy space in a riser cabinet. It runs off a standard 240 volt outlet and uses about 500 watts of energy. So you don't need to do all this extra electrical supply. You might even supplement with the UPS to run the network unit. All coverage units fed from it on the dual Cat6 cables are power over Ethernet powered from the network unit. So you have one 240 volt GPO feeding the network unit and all connected, directly connected network units. Now, that's 100 metres of Cat6 cable, or you can extend it by putting up to 200 metres and an extender in the middle. If we need to go further, we can use fibre between the network unit and the coverage units, and you can go up to 2 kilometres for that. So you can cross between building boundaries. You can do other interesting things. When we did MARTA, we put the fibre extender hub in, and we had choices about whether to put that in the neighbouring building, there's 2 buildings conjoined, to put it in there and feed over there, or to keep them together and just use it as a 12-port system. Very flexible. So, Les, we'd look at your property, your existing resources and space, but to be fair, if you've got room for a VCR and a cabinet, you've got room for a Quattro 4000 network unit. And by using short cables from antenna to NU, what we're doing is we're maximising the RF energy levels that we receive. We're minimising the losses is what we're really doing. And we're getting every bit of network energy we can into the network unit to deliver power out to the coverage units. Because one constraint with this system, everything has natural constraints. The output power of the coverage units is small in relative terms. 16 dB, if people who know what a dB is. So we have to make sure that all of that energy out of a coverage unit is used as efficiently as we can. What we found in an optimum design is typically the best thing to do is one coverage unit serves 4 antennas and about 1,850 to 2,000 square metres of space. We could do 6 antennas if they're tight, but typically 4. It doesn't increase your coverage when you add more antennas. You just have less energy out of each antenna and you have to be more precise in your positioning. Now, if we're talking 2,000 metres per coverage unit and you can do 12, that's where the 24,000 square metres comes about. It's a conservative figure. So we're comfortable with the claims by the manufacturer that the system can do 25,000 square metres because we've seen that too.
Thanks, Stu. couple of the questions here that I think they're actually linked. I'm going to link these two and see if you can answer them in one go. So there's a question from Sean at Optus and another one from Nithya at St Vincent. So Sean's question is about self-eye qualification for use in high-rise buildings and other areas prone to interference. So there's that component, but I think that also then leads back into Nithya's comments about, is there an opportunity to include this type of technology within the MCF guidelines? And we've recently seen kind of changes and updates, etc. So just maybe your thoughts on connecting those two kind of together in your response.
Yes, thanks. So there's no qualification tool for which self-eye goes where. However, the processes that we follow, and I'm glad of, require us to submit our study, so our pre-installation study about donor signal quality, to the operators for pre-approval. Now, the advantage of this is that they are in possession of information that we will never be granted access to. We will never be told how much headroom capacity is on a particular tower or on a particular sector or on a sector of a DAS. That is sensitive commercial information held by the operator. It also changes day to day. So we submit our design to them and say, this is what we're looking to do, and these are the donors we want to use. Do you agree or disagree? Now, of the 52 odd sites that we've deployed, we've had 2 sites where we've been asked to use the secondary site, not the primary site. And so we've been happy to do that. So that qualification has been provided to us. And I think that interaction with the operators is vital. I'm not sure everyone is doing it. I'm not sure how they'd be getting around it, because I understand that it is a procedural instruction. But I really appreciate, having had a relationship with various parties in the carrier side of the business, that we're respecting the hygiene of their network. We're actually delivering a solution that is going to uplift the experience of the customer, and it's not going to be detrimental to the operator. That's what we're looking to achieve. Now, the other half of the question, David, can you just remind me what that was?
So that was then just about MCF guidelines. And
yes.
Yeah.
So the MCF for years has basically given scant regard to repeater deployment, because it kind of doesn't matter to the MCF. Repeaters tend not, so the DAS that are repeater feeds tends not to be shared with the other 2 operators. Typically, repeater DASs that were put in over the years, if one carrier put one in, the second carrier put another repeater DAS in, and there'd be 2 DASs in the property. Repeaters are much lower energy. They tend not to, they can cause interference if they're badly installed, but they tend not to need to manage the high power levels that are from a base station. The MCF is a set of guidelines that was originally written for the 3 operators to collaborate better. Not sure they always do, but the fact is it's designed to do that. Then it became sort of the de facto spec to be used by the third-party market, so that a DAS would be built that the carriers would connect to. Repeaters don't have base stations, so that really doesn't apply. When you go into the MCF, you'll often, in fact, I think the most recent one carries the same thing. There's one sentence that says, yes, repeaters are a possibility, but we're not really focused on them in this document. The latest MCF reduces from about 87 pages to 58. I haven't actually seen the comment about repeaters, but at the moment, I don't see that the MCF is particularly interested in considering a product like Quattro 4000 as a shareable technology between the 3 operators. And it's a bit of a pity, because it's out of the box straight away, 3 operator networks and a 4th to manipulate how you want to. And it's a pretty good solution for a 3 network operator solution, but it's not covered in the MCF, and repeaters aren't.
Steve, there's a couple of other connected questions. Now, this is great. The stuff coming in is really nice, because I can link these together. There's a follow-up from Vern, but there's also a question from Karam, and I'm going to touch this in a couple of ways. One, approvals. So carrier approvals around the technology, right? So Vern's question is, kind of what are the timelines from the MNOs for potentially large deployment solutions, etc. And Karam's question, kind of, it talks about repeaters, and it talks about things like, kind of the value and the appropriateness of using technologies where you may already have outdoor sites operating on full load in peak hours. So kind of the appropriateness, and maybe you can answer that thinking about what we've done with our design philosophies when we talk about carrier pre-approval works and, you know, kind of network design, tower selection, etc.
Yes, okay. So approvals and pre-approvals are quite rapid. We're complying with the documentation requests of the operator. We submit them to them with the appropriate information. They're comfortable with the deliveries we've done. We're very proud to say that we've done over 50 of these sites. It keeps growing at quite a rapid pace. And if you think 50 since May 2023, we're sort of in November 2024. How many months is that? About 18. And we've done 52, 54 on sites. And these are pretty large sites. They're not like a self-IG 41 site or something. These are quite substantial, as we say with the hospitals. So I'm pretty pleased with the turnover of those things. That's required pre-approval to be provided before we did the work. So that reinforces the question, how long does it take? In simple terms, we've often received our pre-approval to our submission within 72 hours of submitting it. Now, we don't hold them to that. It's not an SLA. They're busy people. But we're doing the job as effectively as we can to make their life as easy as possible, and they're saying go ahead. Of the 52, I can really only recall 2 where we were advised to use a different donor site, and that was by one operator. So 2 sites, one operator saying, no, point a different direction, please. We also have another site where about a month after we put it in, the operator's service went sour. There was no evidence as to why. Fortunately, we had a secondary source, and we rotated the rooftop antenna around to the secondary source, and service was made good. We don't know what changed with the primary tower. We've never gone back to look at the primary tower because the secondary source was quite adequate and the customer's experience was resolved. That was sorted out within about 72 hours in terms of technician time. So these are not perfect, but they're very, very nimble and flexible, and we like to be just as nimble and agile in dealing with our customers.
Yeah, and I think that's a really good point, Stu, that kind of carrier pre-engagement to kind of be guided by the carrier on the most appropriate donor signal, where the carriers will guide around capacity at peaks and areas of what's the most suitable donor. But to your point as well, that ability to, as we might call it, repan donor antennas to a secondary source where required. Now, you could deploy a solution and 12, 18 months down the line, someone decides to build a huge new building next door to you and block out signal from the existing donor signal. So you can repurpose the technology to pick up an alternate signal in that requirement.
Yeah. The other thing is occasionally towers get decommissioned caused by community feedback or other things. So you could be working off a tower that has a sector turned off or has other things happen, and we need to respond to those things. The other question was about value and appropriateness. Well, they're extremely good value, these things, and where we've deployed them, they've been appropriate. But we have been willing to say, no, that's not the right product for you, to customers. Now, customer is always right. They're not always completely right. Sometimes we've been directed by a customer to go and do this because there's no alternative. There's only this, and I want you to do it. Now, we'll be pretty clear in our explanation that this is a risky strategy. On the same token, the carriers have been very conservative, even advising us at the beginning that our work with David was not recommended because it was a hospital. They were concerned that there weren't good donors in the area. They didn't stop us. They just said, these are our doubts. We went and checked the quality of the donors in the area. We found 2 very good and 1 good. We proceeded with the deployment. And while we haven't bitten the cherry a second time with David Sorbia has, well, I think his hair's growing back because he's got less stress. And I think that's a good outcome. We're looking to give people less stress, and maybe my hair would grow back. I'm not sure if that's actually possible. We're looking to give people low stress solutions. Any other questions?
Now, look, I think we are literally just a couple of minutes over, Stu. So we'll wrap up. Maybe if there's a couple more in the feed, we will respond to those questions to the people that have asked them. So I obviously just like to thank both Stu and David Sorbier for their input today. I hope the audience found everything informative and of interest. Whilst there's probably a lot of complexity and pitfalls around this subject, you know, the importance is engaging the right support at the right time. To everybody from the audience, thank you for giving us your time today. From the webinar finishing, we'll send out a link to the recording of the session and the survey for your feedback. And please reach out to either Stu or myself if there's anything we can do more directly in the meantime. We hope you have a great day and look forward to seeing you on one of our future webinars again soon. Thanks all for your time.
And thank you, everybody. I really appreciate your attendance.
Thank you.